So data presentation. We can see scattergraph. Scattergraphs are first-class techniques when we're trying to identify relationships between two variables. The two variables here, on the x-axis, we've got distance from source, and on the y-axis, we've got velocity. So we're trying to identify if there's a relationship between distance from source and velocity on the long profile of the River Chalmadale, Isle of Arran. And our results show there is a relationship. Our line of best fit shows a positive correlation. As we move from source to mouth through the upper, middle and lower course, velocities are increasing. But there's also two anomalies that we can highlight with this graphical technique. First of all, anomaly number one, this point doesn't quite fit in. Here, we'd expect the velocities to be slower, but we can explain it by talking about landforms. This is an area of whitewater turbulence where the riverbed and the riverbed's geology has led to this turbulent white water, which has led to faster velocities than what we'd expect. And landforms also explain this second anomaly. This is in the lower course of the river. We would expect the river to be very, very fast by this point. But it's not. It's slowing down. And that is because this is an estuarine environment. The landform here is an estuary. It's where the flow of the river meets the tide of the sea. And that interface slows down velocities. Let's evaluate this technique. Let's look at some what went wells and some even better ifs. So the what went well. This is a fabulous technique for identifying relationships between two variables. It's incredibly visual and it allows us to identify patterns, trends and anomalies. And we can use those patterns and trends and anomalies and explain them talking about processes and landforms. The EBIs, lines of best fit, the subjective, they're subject to our views and opinions, so they could be inaccurate and therefore we could misrepresent patterns and trends.